There are two ways to connect electrical components. One is a series circuit and the other is a parallel circuit. And both circuits have their own characteristics. To start off, a series circuit like this one is where components are connected end to end in such a way that there is only one path for current to flow. So it's flowing through each of these components. If one of the components along that path is broken, the entire circuit stops working. The most common example of this is Christmas tree lights. When one bulb goes out, the rest follow. Next, there is a parallel circuit. A parallel circuit is a type of electrical circuit in which the components are connected across common points or junctions, creating multiple paths for current to flow. That means for this circuit, the current can flow through multiple paths, and each component has its own separate path to and from the power source. For a parallel circuit, you will find that if one component goes out, the rest will still work. These two circuits are important for every owner and technician to keep in mind, particularly when wiring batteries together. These two circuits will change the voltage and amperage of your battery bank depending on which one you're using. If you have a set of two 6-volt, 220 amp hour batteries wired in series, which is positive to negative, like you see here, the voltage will add together to get that 12 volts, which is the required voltage for most RVs. But the amperage for this setup would stay at 220. Now, let's say you had two batteries that have 12 volts and 750 amp hour ratings. If they were wired in parallel, like you see here with the positive terminal to positive terminal and the negative terminal to negative terminal, if they were wired in parallel like this, the amperage would combine to give you a total of 1,500 amp hours, and the voltage would stay at 12 volts. There's a third option which combines these two circuits. When you have a set of batteries grouped in series parallel circuit, you will apply both concepts. Looking at this example can be a bit confusing, but what I like to do is imagine the batteries combining to create one large bank. Let's start off by merging our batteries that are connected in series. Those grouped together would give you 12 volts. Next, we combine the sets wired in parallel. This increases the amperage to 1,500 amp hours. So our rating for our battery bank is 12 volts and 1,500 amp hours. In this series parallel battery configuration, you effectively combine the benefits of both configurations. You achieve a desired higher voltage from the series aspect, while the parallel aspect increases the overall capacity. This dual benefit is crucial for applications that demand specific power and energy and spreads the load across several batteries, which can increase the overall lifespan of the battery bank.